A web server is a software that serves web content through the HTTP protocol. It is the foundation of the internet, and any website out there must be sitting and hosted by a web server. Web APIs like REST APIs can also be hosted on some sort of variation of a web server as well. Web servers can serve static and dynamic content. We're going to talk all about that. And you can use an out-of-the-box web servers like Tomcat or Apache or Lightly. Is that what it's called? I think it's called Lightly. Or you can build your own from scratch, like you build using a framework like NodeJS or ExpressJS or Python Tornado, right? You can do all of that stuff with a web server. Okay, in this video, we will explain what is a web server, how it works, and we'll go through and spin off two types of web servers. One of those like ready-made web servers, which you can just install and just put static content on it and let it work. And we're gonna also explain how you can write almost your own web server from scratch using the web framework. We're gonna use ExpressJS for that, okay? But I've made a lot of videos about Python and web and Node, so check out the content in this channel, right? So speaking of which, if you're new here, welcome. My name is Hussein, and in this channel we discuss all sorts of software engineering. By example, we have tutorials, programming, we discuss software engineering concepts like what was a web server, was it a proxy, NAT, right? Anything that particularly interests me, I just add it as a thing to do in this channel, and in order for me to learn. If you're interested in that kind of things, hit that subscribe button and hit that bell icon so you can get notified whenever I upload a video. That's it. Let's just jump into this video, guys. All right, let's just jump into some, hopefully go through this theoretical part so we can show you some coolish stuff. And I'm going to add some jump codes here. You're going to see it here so you can just jump to your favorite part of this video. All right, we're going to talk about what is a web server in this agenda. We're going to talk about how web servers work, and we're going to show you the examples, right? This is our agenda for this video, okay? What is a web server? It is a software essentially that serves web content, period, okay? Define what web content is. It could be your HTML pages, could be just images, PDF, right? Anything that can live as a web and transferred as a web content is defined as web content, okay? Your API could be web content, right? Your JSON document is a web content, okay? Anything that's sent back text, right, can be web content. That's the definition of that, okay? And it's consumed by clients who knows how to consume web content, okay? Let's talk more about that. That's why it uses the HTTP protocol, and guess what? We have made a video about the HTTP protocol. I'm gonna make it reference here. So if you want deep dive into what HTTP exactly is with examples, go watch that video. I'm going to reference it here. But essentially, it's the hypertext transfer protocol, was designed, and there's different versions, different semantics, right? But we are now in HTTP 2. HTTP 3 is coming. HTTP 1.1 has been living for almost 20 years, and essentially this is what the web runs on, okay? Right, and that's when you say like HTTP // that's you're using HTTP protocol. Okay, if you don't want to learn more about it, go there. And all right, static versus dynamic content. So what does that mean? Okay, if you're like me, born a millennial, born in 1983 or a little bit earlier, a little bit after that, you would remember the early days of the web, where those flashy marquee text and the moving stuff, where the web was essentially just you consume stuff. Okay, you cannot really change anything in the web as a user. You can just consume. It's a static content. It's just a bunch of static content, HTML pages, right? Most of which were run on Apache, by the way. All right, so that's like the state of the art in the 90s, if you remember. Okay, so all these flashy images and essentially static content is like index.html, index pages, HTML pages, PDF, images, CSS, right? I don't know if the CSS existed in the 90s or not. JavaScript files also considered as a static files, which is funny because it's actually code, but it is, nevertheless, it's a static file. It's a file that you can download, and that's it, okay? And here's the interesting part with that. Static file, so you can host a web server and you can put static files on them and you can serve those very easily. We can show that. Okay, that's the cool part of the web application. So you author content, you paste it in a folder in your web server, and then your web server will immediately generate these nice URLs for you, the HTTP slash whatever the folder you created, and then blah, you can host your pages, which is pretty cool, right? So people, instead of sending files by emails, you can send people link URLs or URIs. Okay, and then they will go to your content. So static files are cool because they can be cached, because no matter if they change, you can detect this change using e-tags and caching. Okay, and I'm gonna reference this caching concept here if you want to learn more about it. Dynamic content, on the other hand, is when things like blog posts, right? It's a query to the database and will retrieve certain results. So based on the login user, you can get different content, different page. Facebook is an example of this, right? It's a dynamic. Nobody have the same web page ever. Okay. So caching this is a little bit tricky. Okay, so that dynamic content. Dynamic content is generated as a part of a language that you write. You write code in the backend that generates different content, different page or web content based on a different context, like could be the user, or it could be just the location. If you're coming from Asia, you're gonna get a certain like look and feel. If you're coming from America, you're gonna get a different look and feel. So that's the dynamic content essentially. Okay. All right, use to host web pages. We talked about that, right? So we can use to host web pages. You can use, that's the 1.0 era, just web pages. You can use blogs and forums, right? Where you can, that's the web 2.0, right? Web 2.1.0 is just everything static. 2.0 is when things started to allow users to actually interact with these pages, like create a comment, post, right? Do something, and then you can see these changes. So there's an interactivity between the web, right? And you can also build APIs, right? We talked about APIs on this channel. I'm gonna reference some videos here we made about how to build a REST API with Python. You can also check my course there, Python in the backend, if you're interested. It's all about APIs and how you can write Python on the backend. Little plug there. All right, so how web servers work, guys? How do those things work? I'm gonna talk about concepts here that I explained before, so I'm gonna gloss over them, like TCP, what TCP is, right? So if you want to learn more about TCP connections, check it out here. But essentially, what happens here is if a web server, this is a client, this is your web server, and this is your client, could be a laptop, could be a mobile phone, and it's requesting a page. And what it happens here is your IP address you have an IP address. That site will have a domain name. It could be having a host name, and then it is running on a port. Usually this port is 80 for web servers. Okay, that's the default port. And if you don't see a port on the URL, that means it's port 80. But you can also run web server on any port you want. Okay, that's just the standard. 80 for HTTP, 443 for HTTPS. All right, so and when you have a web server running and listening on this port, that there is a TCP socket or connection ready, right? And if you make a request, let's say get, that's the HTTP semantic we talked about, get me the index.html page on the example, right? And this is a syntax for HTTP. And when you do that, the server will process that request, perhaps maybe query the database. If it doesn't need to, just pull it from a cache or just pull it from the directory and just serves you back the result. And then when you sends you the index.html or whatever that HTML page, and it also sends you a bunch of stuff in that response. We call this the headers and a status code. Okay, and the status code is like, you might have seen the 200 okay or 404 not found, things like that, right? So the web servers have these HTTP codes that, and I want to make a series about all type of HTTP codes, hopefully. Okay, so that's the nutshell of that. But let's go dive deeper for those who are daring to dive deeper into this. Okay, so another example of a web server, one example of this is what I call a blocking single-threaded web server, and I decided to explain that because it's the easiest to explain. Okay, obviously none of the web servers work like that, and well, I take that back. So some web servers work like that, and there's benefits of that, but most web servers have different implementation. So let's talk about it. What exactly happened when I make that GET request. Okay, so this is my web server. I just made it into a box so we can draw stuff in it. Okay, and then when a client makes a request, whether this GET request, there is something happening before that. Okay, HTTP protocol runs on a transport layer called the TCP, Transmission Control Protocol. Okay, so a transmission control protocol, what it does is it establishes a two-way communication between a server or a client. Okay, but the HTTP protocol is just a request response. So if you make a request, the first thing it does is establish this TCP connection. So there's like some handshaking going on. If there's a TLS, you need to establish the TLS. If there's a secure thing, and then once you do that, the server creates in its memory, and very important here, memory. Let's focus on the word memory. Every client that connects reserves a little bit of a memory on the server. Okay, that's where things can get really tricky, right? That's where all the attacks, denial of attack, happens because of this reservation of memory. Okay, reserve a lot of memory and your server crashes. Okay, but okay, your client connects, you reserve a little bit of a memory, and this thing is called TCP socket. You reserve a socket for that client. Okay, and once you reserve a socket for that client, now you see, okay, we have one thread, one process with one thread that is allowed to execute stuff. Okay, you can have 10 of those sockets, but they are sitting in memory. They are just idle. Okay, but your process can only execute one at a time. Okay, so I'm free. Your thread is free. Let's say there's a thread here that starts executing and says, okay, oh, you want me to get index HTML? Okay, let me go do an IO desk or whatever, right? And then start getting busy. That thread means it's the sock is busy. It's doing something. That process is busy doing that. And that means that thread cannot do anything else while it's doing that. Okay? So based on that request, and that's a very simple request, but there are many requests that actually pulls from the database or does a processing, calculate, I don't know, prime number, right? Do your web API thingy. Okay, that's the tricky part where you need to do short circuit breaking, say a circuit break, and just break the circuit if the client executes for a long time. You execute that, you release, the thread is back, and it's back in normal. The client got a response, and we're good to go. So what happened now? Okay, so let's say the client makes another request. It can use the existing TCP connection. It doesn't have to create a brand new TCP connection, which is kind of fast. So having a TCP connection open with the server is a kind of nice thing. There's a bad thing about it is just you're reserving memory on the server. So if you have a TCP connection that is open and you're not using it, you're wasting server memory. Okay, but yeah, pros and cons of this, and we talked about the HTTP, and then we go execute and then release. All right, let's make this a little bit spicy. Let's add another client. Okay, one client makes a post request. That's the write request to the server. Okay, so I want to write something, like I want to create a new to-do list in my API, and the web server takes that and start processing. Then guess what? As a poor Joe Slop here want to connect to the web server, okay, and the server is a little bit busy, and now the web server implementations shine. What do you do? What do you do as a web server implementer? Apache does one thing, Tomcat does the same thing. All right, NodeJS does another thing, Python does another thing. You can do whatever you want if you write your own as well. Okay, you can do whatever you want. But here's what a blocking single-threaded does. Okay, it creates that TCP socket for you, and that's it. It just does that. It creates a place of memory for you. But guess what? Sorry, I can't serve you. Yeah, the only thing I could do is just create that socket for you. Yeah, you have a TCP connection. Booyah. That's it. But I'm busy serving this guy now. Okay. That one thread is busy serving that. Okay. And then once you basically done, right, this guy can be served, and then you release and you're done. Okay. Some some of you might say now, okay, can you just spin up another thread? Sure, that's what Apache does. It spin up a new thread for every single request. Okay, and that's why you'll see when you go to Apache or Tomcat, there is a parameter called maximum thread numbers or maximum connections, right? How many of those do you want, right? I cannot just have unlimited, right? Well, you can change it to unlimited if you want, if you have unlimited memory here. But think about that when you really work with web servers. I like you to think about all of that stuff. It is really interesting to know how stuff works, especially web servers, because we work with these as software engineers. I mean, writing REST APIs, this is very critical to understand, guys. Okay. So your implementation of how it looks like is very critical. So you might be happy with a single threaded blocking, okay? But you might say, okay, I'm gonna spin multiple web servers like that, okay? So I'm gonna put them behind a load balancer, and that's fine. Why not? Right? I don't see anything wrong with that. Must be some limitations, right? You can put in Docker containers. You can spin up as many containers you want off single threaded. I find this way more simple than having complex thread multi-threaded app web server, right? Let's have a discussion in the comment section, guys. What do you think is a better way of doing things? Okay, there is no right answers or wrong answers here. Okay, people still debating this. Okay, don't think this is set on stones, right? Don't just absorb information, discuss, right? Challenge everything that you read. Okay, nobody's perfect. Example. All right, example. I love this part. I love this part so much. Okay, so I did a Google search on some of the web servers, right? The one I knew was, to be honest, I knew HTTP. I didn't know it was called HTTPD. By the way, this is Apache. It is the other name for it is called HTTPD. I know IIS. I work with IIS most of my time. I work with Tomcat almost on a daily basis. My current job, right? I use HTTP server all the time when on my YouTube videos because it's the easiest thing ever in life. Okay, light HTTPD, which I think they force you to say lighty. I don't know why it's called lighty. There is an H, there is a G, there is a P, there is a D. As a foreign, like, non-English speaker, this is all wrong by all means, you know. So write your own. That's another way of writing. So you can use an existing web server, or you can write your own. You can just use Node.js as a framework, a web framework, or you can use Python Tornado. So guys, you can write your own web server as well, right? And you can use Node.js for that. You can use Python Tornado, and that gives you the bare metal bones of things. It gives you how to listen to a port, gives you how to send statuses, it gives you how, hey, there is a request and a response came. Do your thing, okay? So it gives you essentially a blocking single threaded, okay, server, but you have to write all of that stuff for yourself. Okay, these guys does most of the work for you. If you have IIS, you can just write an ASP application. I forgot what ASP stands for. ASP.NET Active Server Pages, I think it says that. I think something silly like that. So yeah, for Microsoft, you can just really enable IIS and just copy ASP.NET pages, and then there works like that. For the demo part of this, guys, I'm going to show you how to spin up Apache 2, which is HTTPD also, okay? And we're going to show you, I'm going to show you how to spin that on my Raspberry Pi because I have Linux there, okay? That's the easiest thing. All right, and I'm going to show you how to do your own web server using Node.js Express. All right, guys, so here's what I want to do. I am logged in here to my Raspberry Pi, which has a Debian distribution, and I'm gonna install Apache 2, which is HTTPD, which is the Apache web server. Okay, and this is one of those ready-made web server where you can just throw a web content at it like HTML images, and you just will serve it for you. Very simple stuff, right? And so that's like the easiest way of hosting a web page or hosting, blog or things that if you want to host a web page or some like a company website, this is the easiest thing you can do, right? So let's learn how to do that. Okay, so to do that, since I'm using Debian, I'm gonna do the apt get here, sudo apt get install. It's called Apache 2 for some reason. Okay, maybe the first version sucked, so they made another version. It's called Apache 2. Okay, if you're using Docker, it's called HTTPD. Maybe we'll show you how to do that on Docker. So let's go ahead and install. It's gonna take a while. I'm gonna pause the video and show you back whenever this is done. I really can't believe that this is only 361 kilobyte, which is pretty amazing if you ask me, right? This is really, it's written in C, I think. So, or C++, I forgot. Last time I checked, it's written in C, so it's a very, very small footprint, right? Unlike Tomcat is written in Java, and it is really heavy stuff. But you can do way more stuff in Tomcat, obviously. But yeah, it's done. That's it. Okay, we just installed it. Well, in your case, I have installed it before and then I uninstalled it, so you might need to do it sudo apt get update and then sudo apt get install Apache 2, and then you will have it. So what do? Once you install it, you go to a folder called var www root, and there is a folder called HTML. Okay, and there is literally a page called index.html they give you for free to test your stuff. So let's go ahead and see if that works. All right, guys. So I am here on my Mac. My Mac and my Raspberry Pi on the same Wi-Fi, so I can access that stuff, right? So I'm gonna go www.raspberry pi.local. And by default, the Apache 2 listens on port 80. So this spins up the server on port 80 by default, okay? So if I do that and then runs, and you can see, it works. And I'm using Debian, obviously. Okay, it tells you that you have your Debian distribution. But essentially it tells you what to do as well. Copy stuff in that, and you get yourself a web server that can serve anything you want. Okay, so since we guys are curious, let's do that. Okay, first of all, I'm not the owner of that thing for some reason, so what I want to do is I want to change the owner of this thing. All right, guys, so before we create our own HTML page and do fancy stuff, I want to own that HTML folder here because I'm not the owner of it. Okay, as Pi, the user. Okay, so what I want to do is go back a little bit, and then I want to do a sudo chown, which is change owner, and the chown this thing from Pi on this folder. Okay, so that means the owner of this is moi. Okay, moi can now write stuff in it because previously I couldn't. So first thing I'm gonna do, first order of business, remove this file. Okay, and I'm gonna create one from scratch called index.html. Okay, and it's fancier. It's gonna be fancier. I'm going to do hello world. This is my page hosted on HTTPD or Apache 2 because the first version sucked. Okay, body. Did we close that? Yes, we close this, and then we do dit, and then that's it. We just created an index.html. Let's go back to my Mac. All right, we are on my Mac. I am about to hit refresh. Hopefully, my server is smart enough to not cache that page. And guess what? It worked. It worked. All right. And you can pretty much put any stuff there and it will just get hosted for you. Okay. And let's say, for example, I don't know, let's do a main.js file here, and that does literally an alert. Hello world, I'm JS. Okay, and then we can edit my index.html, and then we can do fancy stuff like that here in the body, saying script source equal, what did I call it, main.js. Since it's in the same folder, we can get away with that, so let's do that. And then when we refresh, we're gonna get an alert because my JavaScript got executed. So what happened here, if you literally took a look of that, right? When you refresh, two requests made, right? The first request is to get the index.html. This is the 200 OK. Obviously, we talked about that. We got back an index.html. It's a text, right? And that thing, when parsed by the browser, discovered that there is another thing it needs to pull. So that's back to our TCP connection thing, guys. So if in HTTP 1.0, these two was two TCP connections, which is extremely slow because every request will start the TCP connection and close it at the same time. Now there's something called keep alive. I'm alive. Oh my god, this video is gonna get demonetized. All right, keep alive. All right, so it's gonna keep it alive, keep the connection alive, baby. That's what it. Yeah, keep the spark alive. So once it keep the connection alive, the second request, okay, will actually make that request to get that main.js. Okay, obviously when you write your own web server, you have to do all of that manually. You have to do the caching manually. You have to do all that stuff. But this guy, the Apache, does caching for you, okay? And let's prove it. So 304 not modified, that's the E tag. Okay, guys, I'm gonna reference the E tag here. Go check it out. What is the concept of that? But in a nutshell, this is the caching mechanism. So what the first time, let's disable caching and let's show you that. The first time I make a request, okay, to any content, I get back an E tag, okay? And the client then use that E tag with every single request it makes, okay? So if I make a request now, and the client sends that request, says, hey, if none match, tell me, did this E tag change? Tell me. If it didn't change, coolish, okay? But in this case, the JavaScript didn't change. So it says, nah, you're good. Whatever you have is good. Okay, so let's see how good the Apache implementation is. So I'm gonna go ahead and do main.js, and I'm gonna edit that thing to say alert, hello world, I am JS, and I just changed, baby. Okay, and sure, let's do, I don't know, another alert message because that's the only JavaScript code I know. I'm kidding, guys, I'm kidding. Oh my god. All right. That's another JS, right? Let's see if the implementation of the thingy is smart. So I'm gonna go ahead and what was our original? I lost it. Dash. Okay, no problem. It was a certain E tag. The client will attempt to send the same E tag, but what? Look at that. We got the new stuff. That's another JS, right? So what happened here is we sent it the same E tag, but we thought, nope. We got a new A tag, okay? I don't know what gzip is. We're zipping this thing? That's what. It's just like the implementation of the actual web server here, okay? So the web server says, nope, it has been modified. All right, so that's essentially the trick, guys. That's it. Simple stuff. Let's show you how Node.js works. How about that? Right? So we're gonna write our own implementation here. So in order to write our own implementation, we need some decent editor. We cannot use Vim. I mean, we can, but yeah, it's just a lot of work. Okay, all right. So I have Visual Studio Code here. I have Node.js installed. Go ahead and check it out. I'm gonna reference a video that we have installed with Node.js and all that stuff. What I want to do essentially is just create a brand new folder with Visual Studio Code. let's call this web server from scratch. Okay, and then just a brand new folder. There's nothing in it. Okay, and you go here and then you click on this guy and it will create a new file. And that file, because I'm writing JavaScript on the back end, you have to write your own code here to do everything, okay, to serve a web content here. So I'm gonna say index.js, and I'm gonna create our index.html page here. And since we are in the editor, we can actually write the entire HTML with just one click instead of having to write everything. Hey, H1, hey, I wrote all of this myself. NodeJS, babes. Okay, so that's the HTML that we want to serve, but we need to listen to a port, we need to receive requests, we need to send requests, we need to do all of that stuff. So let's get into it, guys. So, and you pick then at the end of the video, you pick what is the favorite part for you. Okay, so I'm gonna do an app here, const app equal require express. Okay, and that's just the bundle. So we need the app, we spin up a version of that. Okay, that's like literally a function call or constructor or tar, ctar. I don't know why everything is an abbreviation with people. Okay, constructor. Can't you say constructor? Really, you have to type tar. Oh, I know, man. API people, guys, I'm telling you. App dot. Here's what I'm gonna do. App dot listen. You're gonna listen to port 8080 because 80 is kind of reserved for highly privileged apps, and I'm not one of them, so I can't listen to them. I have to run as a root, and I don't want to. So let's just listen 8080, and when you're done, you say console.log sup, I'm listening. Yes, what do you want? Okay, this is just for what the heck is happening. Okay, this is just for us to know that we're listening correctly, but that's not enough. Okay, well, let's run it so I can show you. Okay, I have Express installed globally, so that will work, right? But that's it. Sup, I'm listening. Yes, sir. What do you want? Okay, that's it. Okay, but that's not enough, right? We need to really accept the request. That's if I do that now. Let's see. If I do that, and let's say run. Let's just say localhost. Right? See the error I'm getting? So now, guys, if I go and try to go to localhost, which is my machine, 8080, I'm getting this error. Cannot get. Why? Because you didn't implement anything, right? There's nothing there, okay? If you refresh there, look at all these errors. Forget about those, but look at that, 404. Because that's the only thing that the application does. It says, hey, there's nothing on that server. The server is dead, okay? So here's what we need to implement. We need to implement a get method, a get slash method on the root, okay? So that's the first thing we need to implement. Remember, we didn't have to do any of that, okay? We have an index.html, it didn't get served. We have to tell it to get served. How? We can do app.get on the slash. If someone visited me on the slash on the root, I want you to call this function. And this function always has to take two parameters, request and response, okay? And then what you do essentially for simplicity is you don't really care about the request. Sometimes you do, obviously, but here we don't. There's nothing in the request. I just want, if someone visited me, I just want to send file, and then you send it the index.html file, okay? And to do that, we have to do all that stuff where it's in my directory. This is to avoid hackers pulling over your stuff, so you have to specify. You cannot use relative files here, so you have to do that, okay? So that will take the directory name and then index.html, okay? So that will serve the index.html page, okay? Let's try this. Restart, and now if I refresh, hey, I wrote all of this myself. Node.js babes, okay? You like this, babes? You like it? This is the best, right? This is the best. And if you served another file, you have to do the same thing again, okay? anything. Okay, there's obviously regular expressions that you have, like any. If someone visited anything, then serve them anything. A little bit dangerous, but you have to know what you're doing. But that's essentially how you write web content. Can you do something else? Sure, sir. You can do get slash sup, anything you want, really. Then request response. You can do, and we have the function here. We can, for example, just send a result, anything we want, text, hello. Okay. And then if I do that, all right, if I go to localhost 8080, I get this. If I do sup, I get hello. And let's see what did we get back from the headers. What did we get back from the headers? We get back 304 not modified, and we got back the results. Okay, and now can I change that? Yeah, sure you can. You can do result dot status code, and instead of 304 you can change it to anything. 404. What is the 404? You guys know, right? 404 is not found. Although those found, right? You can tell it whatever you want. That's the flexibility you get when you write your own web server. Okay. Although the document is there, you can have an if statement. Hey, if this exists, do that. If this, do that. You can add all of kind of stuff like 201 code, which is, I forgot what it is. I think accepted or something like that. And created. Right? You can do anything you want. All this stuff. If you change this to 418, for instance, right? This is one of the April Fool's status codes that have been created. Look what you get. I'm a teapot. I don't know what the heck is that. You can actually change it to whatever you want. Okay, get what 418. I am a teapot. That's one of the status codes that is being documented and it's gonna be there forever. Alright guys, that is our video today. Hope you enjoyed it. Give it a like if you do, and if you learned something, subscribe to learn more and share this with your friends. And I'm gonna see you in the next one. You guys stay awesome.